Okay, welcome to yet another completely different topic, electric fields. But to start off, we're going to start off by looking at some syllabus objectives, right? We always like to start off by looking at the syllabus. So we need to understand what an electric field actually is. We need to understand how to define an electric field, how to use the equation F is equals to QE, as well as how to represent an electric field by means of field lines. Okay, so those are the three objectives that we're supposed to cover. And in this video, we're supposed to understand how to define all three. Okay, so to start off, we need to understand what is an electric field, right? Which is a very simple but yet difficult question to unravel. So previously, an electric field was used or was defined as being a regional space in which an electric charge can experience a force. So we define an electric field as a region of space, right? This was a qualitative definition though, and recently the definition has shifted to a more quantitative one. So essentially, you can be able to define an electric field as follows. It is defined as the electrostatic force per unit positive charge. Okay, so if you have a positive charge, that is present over here. So this is my big positive charge. What force does that charge experience, right? It can be an attractive force, it can be a repulsive force, but what force does that charge experience? That is an electric field, right? So questions can ask you, hey, define electric field, right? You define it as the electrostatic force per unit positive charge. Right, so that's the definition that we're going to be using throughout all of our calculations, right? The electrostatic force per unit charge. We're not going to say it's a region of blah, blah, blah. We're just going to say an electric field is the electrostatic force per unit charge, right? You'll now find out that if question papers say electric field strength, it is not the same as just saying electric field E, right? It'll just be a little bit the same. But you just need to understand, though, that if a force acts on a positive charge, that is the electric field, right? We'll use a positive charge as a reference charge always, not a negative charge, but a positive charge. We're going to be dealing with a positive charge throughout all of our calculations. Okay, so we need to understand how can you then represent that electric field using field lines. So a field line is basically a directed arrow that is used to show the direction in which, in this context, a positive charge would move, right? So if you take a positive charge, what direction would it move in? That arrow is essentially what we call a field line. So to state what is represented by an electric field line is the direction of the force acting on a positive charge. So when given a negative charge, the positive charge will be attracted. So we expect the field lines to be directed towards the center of the object. You put a big negative charge, the positive charge will be attracted towards the center. But if it's a positive charge is repelled, right? So if you put a positive charge towards it, it's going to be repelled. So the arrow will basically show you the direction in which positive charges will move if they're placed in a region. So they'll either get repelled or they'll get attracted. We can therefore see that a force can act on a charge that is placed in an electric field, and that force will be equal to QE, right? So since the electric field strength is the force per unit charge, the electric field itself, being the force per unit charge, implies the force that will then be acting on that charge will be given by QE. So that's essentially the little introduction that we're going to have. And since F is equals to MA, and since we said F is equals to QE, QE will be equal to MA. So if a positive charge experiences a certain displacement, its acceleration can therefore be obtained by that above equation. So that's essentially what an electric field is, what the direction of motion implies, and what the force acting on a unit charge actually entails. In the next video, we're going to introduce the concept of uniform electric fields.